Testing, testing. All right. Well, it's 1:30 right now, and I think we're going to get this started. Welcome. This is day one of our summer intern research presentations. Our interns have been with us now for the summer, and they're ready to present on what they've been working on. So we've got some people tuning in from out in Zoom land, but we also have a great crew here. So yeah, without further ado, I think we're going to hand it off to our first presenter. Solomon, you want to come up? All right, here you go, my friend. Your mic and you should just be able to hit
enter button?
no.
There we go. Recording. Sounds good. Hello, everyone. My name is Solomon. I'm a fourth-year computer science student at UAF, and today I'll be going over what I worked on this summer. So my mentor was Dane, sitting over there, and my overall sort of focus area was data collection and management support. Sounds good. So this project is the IRMDA project that stands for the Eielson Resilience Microgrid Data Archive Project, and we're currently in phase 2 of this project. It ends in December. And so what does that stand for? So Eielson, that's Eielson Air Force Base. We drive out the road about 30 minutes to Eielson Air Force Base, and we look at the grid out there, and we ultimately look at what is happening out there. So the grid, of course, has to be adaptable to change. And that means that in order to be out there, it has to be resilient. And the microgrid, which we go out there and we look at, which is the space, it completely islands from the rest of Golden Valley Electric Association. So that means it's completely separate. And that means that for weather events or other related events, for security reasons or otherwise, it's completely able to separate from the rest of the base. We go out there and do physical data collections, meaning that we bring a computer out there and we do the complete data collection from the various sensors that are out there, as well as we look at short and long-term data, meaning that we look at everything from last week to months ago. And finally, we couldn't do it without our partner and partners in this project, which in this case is Eaton Corporation. So the problem statement that we came up with, you can see it above, is how might we better prepare power plant operators with actionable energy metering data for unplanned islanding events to improve overall grid resilience. So what does that mean? That means that for this base, it's a bit south of where we're at right now, and we're looking to provide the power plant operators who make these critical decisions to island or separate the base from the grid, and to provide them the most relevant information possible at a given time. The overall project goals and this sort of focus areas on this project, I'm not sure why they all have ones on there, but they're all equally important, I suppose. You can see that we have 4 overall goals. So first of all, is to design and debug the data pipeline, and that pipeline is what we're able to put all of our data through and from start to finish across the project. Of course, we want to make sure that's secure. We're out on a military base. Of course, it's islanded from the grid sometimes, but it's also air-gapped from the rest of the network. And of course, we want to maintain our data processing systems, existing, past, present, future data processing systems. And of course, we want to support energy researchers so they can do what they do best, their research. Back. A little ahead of myself there. All right, so this is an overall system sort of diagram of what a data collection looks like. So over here, you can see that this is what, when we actually go out to the base, a collection looks like. We're looking at data from a variety of different sources, as well as different file formats. So we put that all together into this collection when we are physically out on the base. And then on this post-collection process, it's everything from validation and transformation all the way into long-term archive and storage. So I'd say that this little box is probably the most important one right here, the raw collection archive, because when we're giving the data to researchers, we want to make sure that they have the most fundamental original data set provided that we collect. And then as you move from left to right, you can see we store the various information in databases as well as flat file. That basically means we're storing just the text file or the raw data that you're outputting. And then you can see that these two boxes ultimately come together and they form these visualizations that we're able to make from the data that we collect. And I'll go into a bit more detail about the various steps along the process as well. There it's, doesn't like. Show it on that screen, sure. So how does this fit into the overall Acep organizational context? Well, of course, when we're going out onto the base, this is far away from UAF. It's about a 30-minute drive, so it's not a rural area, but you can imagine that we're going to a location to collect data, meaning that we can't just pull the data straight from the UAF campus. It has to be secure, so that means that when we go out there, we're following various protocols and to ensure that the data stays safe in our hands, but also is securely distributed to the researchers that we're giving it to. And then the two other aspects is we're ultimately building up this tool set of information for researchers and future Acep people to know best practices that we've learned across the summer and the entire project, how to best go about that. And then finally, this architecture is templated, meaning that if there's another project in the future that we want to go about working on, we can just copy, paste, and hopefully there's some other areas that you might make some changes and settings. But of course, we want to make sure that it's available for communities to build upon as well. So this is the right slide. So there's a couple different tools that we used in our tool chest in order to build up the process. And two that I'll highlight today is Airflow and Grafana. So Grafana is the data analysis and visualization tool that we built up over the past couple months, and it's building on previous projects that we've done at Acep as well. But this is ultimately able to be the front end or showing sort of the graphs that you saw earlier. The other one is new this summer. It's called Apache Airflow. It's an open source tool that we're able to sort of organize everything from start to finish across this project. And I found this is to be maybe the most insightful part of the project is looking at these data pipelines. So there's sort of three steps that you go about. There's extraction, there's transformation, and then there's the distribution or distributing it back to the people that want to access the data. So what does that mean? So you're extracting the data from the base. That's what we do when we go out to Eielson Air Force Base. We transform it, meaning that we perform various tasks, transformations. We make maybe slight alterations, clean up the data so it's best accessed, and then we load it. So we load it onto various platforms to ultimately distribute it to the people that are going to use it and build the research upon it. There's a couple other technologies that we used. Google Cloud and GitHub, you might be familiar with them. GitHub, we stored a lot of our project information on there, kept track of a lot of our changes. Google Cloud, that's where we're hosting a lot of our services. And then the two in the middle, you might not be as familiar with, Terraform and Chef. Those basically help us not only securely deploy our technology out in the field, but also make sure that we're able to provide the best quality program to those who need it. This is sort of the Airflow journey that I've been on this summer. We use this one specific technology called Apache Airflow, and throughout the process, June, July, and August, we started with a lot of tutorials and documentation, and we moved into testing out the workflow through a real implementation of what it might look like out in the field. Going about this process, I think one thing that maybe I would do differently is probably get out of this tutorial phase a little bit faster and go into the implementation, but it's always a push and pull balance of what to work on. Some of the next steps and lessons learned on this project, I think that ultimately probably my favorite part was looking at like the impact that Acep has on the rest of not only our state, but beyond. I think that the projects that everyone's worked on this summer is quite amazing how we're able to have this small amount of time to have this large impact across our state. Some of the perspectives and areas that I think that maybe I would work on a little bit differently is looking through some of the technical terms coming from a computer science background and not a power systems background. I think that there is some more technical terms to learn about, to be more familiar with, and being able to communicate that in a way that's relevant to everyone else. And then finally, I think that showing and not only showing, but learning from the graphs and visualizations and the various data that we collect. It's been one of the most fascinating parts, just being able to do these data collections and then bring it and show it to our stakeholders. In this case is Eaton. And I think that that's been a really interesting part about this summer. So without further ado, I'd like to give thanks to Matt, Dylan, Emily, Keegan, and of course, Dane. They've been super valuable resources when I have questions, and I couldn't have done the summer project without them. Without that, thanks so much. And that was my presentation. Any questions? Thank you. Technology wise. I think probably frustrating is there was a couple times when I was running through these test workflows, and then you sort of have to make the tests, and then as they fail, it's interesting balance that you have to sort of make, because you're running into these tests, but it's maybe at your own fault because you're the one that's creating the test. So finding that balance of how do you make a test that doesn't fail all the time because you created it, if that makes sense. That's been one of the probably most interesting parts and difficult. That's a great question. I think at the very beginning of the summer, there was some sort of insight to go into. I think Matt and Dylan were sort of suggesting that could be a good way to go down. And I think I spent a couple of weeks really diving deep into not only the benefits, but also drawbacks as well of adding a new tool to our technology stack. And the reason why I went with it probably the most is on that slide. If we could go back to the big diagram, this one, yeah. If you can sort of think about all these arrows that are on here, it's a lot of moving parts. And I think where Apache Airflow probably best fits in is each individual arrow, you're able to schedule out tasks on a daily, monthly, hourly, or even weekly thing. So if you look at all the transitions between these boxes, you can sort of think about this tool that we're building out. It's able to schedule a lot of the transitions between boxes. And I think that's one of the more valuable parts. And it's very modular, and it only builds on of what we have progressed on in the last months, weeks, and since the beginning of the project. This nice diagram, I stole it from a previous presentation. So I think this probably came from a draw.io, but if we go to the next slide, one more after that, sorry. This one right here it's called a Mermaid.js. So you're able to sort of write out in code how the diagram looks like. I guess I probably could have done a better job explaining a couple of the different steps in there, but you're able to write out each individual box, and then you're able to connect them all pretty easily just with text. So I'd recommend checking it out. Or we go up to one slide to the tools. Go up. Sure. So question is like, which tools probably work best for this specific data collection? I think that's where I spent a lot of the time exploring what Apache Airflow might be able to contribute to. But I think the two that I'd probably pull out is Airflow and Chef. Chef specifically because we're working on a military base, there has to be very specific configurations to make your device secure, but also, I guess, reliable in different situations. So probably Airflow and Chef, just because of the data that we're putting out into the field and where we need to store it as well. Sure, I think Grafana, this is sort of our front end of the visualizations for everything that's provided. So I think that's probably, from Rich's perspective, that's probably one of the more valuable aspects, because you're able to go straight in there, download a copy of the data, or pull it straight in and stream it straight to whatever service that you provide. So sort of putting together Airflow, Grafana, Chef, and the other tools provided, we want to be able to give researchers the ability to work on the data with. And so that's picking the tools that can help us help the researchers do their jobs best that they possibly can. Any other questions?
Rich Stromberg asked, how do the data tools handle inconsistency?
That is one area of a fun thing that we had to sort of figure out across the summer. We wrote an entire document about, actually Dylan did, about time drift that we found with inconsistent timing. So there's a thing called an NTP server, and there's different time intervals that you pull on. Like if you, for example, if you just threw like a computer out into the field, how does it keep time consistent? Well, there's different ways that you can go about it. And one area that we're trying to investigate is pulling that information from a GPS based time server, but handling inconsistent time format. There's a couple of different tools that you could use. And then one thing that we might be able to put into this data pipeline at the very beginning is a check to see maybe what time zone you're in, or if your initial data is consistent throughout, your date and times are consistent, like going forward, or hopefully that made sense. Any other questions?
Test. So we run